Hi, Christopher.
Hi, Kate. Sorry, I was on mute. How are you doing?
No, you're good. Good, good. I know we're only 2 minutes till start, but are you sharing your screen?
Yeah, let me go ahead and do that.
Okay, perfect. And I think I just made you a presenter.
Okay, cool. I'm just gonna do it through Teams.
Great. All right, fantastic. Well, while we wait for everyone to trickle in, it looks like people are, since it started, there's no waiting room, so everyone's just going to come in. I'll just wait a minute or two till doing a little housekeeping, and then we'll be good to go.
Okay.
All right. It looks like it's we are at time. I'm just gonna wait one more minute for more people to join and we can get started. All right, we are a minute after, so I'll just go ahead and get some things out of the way. Thank you everyone for joining today. We're really excited to go through our TPM update for 2024. This webinar is being recorded, and I think it will automatically send to you from Teams webinar. If it doesn't, I will send a I'll send a email with the slides and the recording linked here. All questions, if you can wait, will be held for a question and answer at the end. And if you have anything, you can always drop it in the chat and we'll address it at the end of the presentation. And with that, I'll just hand it back over to Christopher.
Thank you. Thank you, Kate. Welcome, everybody, and thank you for joining us today for today's presentation for the California Statewide Gas Emerging Technologies Program. This specifically, we're going to go over, as Kate mentioned, the update to our technology priority map, or what we call TPM for short, for this year, 2024. So it's presented by ICF. I'm from Lincus. We're a sub-consultant to ICF, which supported this effort specifically. So today's agenda, just to kind of go over a brief overview at first of what the TPM is and its purpose for those that are not already familiar with this tool and why it's being used, and overviewed for today's presentation. We'll go into the organization, kind of the hierarchy and how things are categorized and structured in this tool. Then we'll go into the general update, the generalized update for this year. And then after that, we'll go specifically into the commercial food service update. So CFS, when you see that, it'll mean commercial food service. And we will go into detail the different updates in the TPM, the new measures, the new CFS measures, but also the updated ones that were already existing, and there are a few that were recategorized as well, based on updated research and feedback we got from experts in the field. So to begin, what is the technology priority map? Basically, we used in the GET program as a part of a technology screening process to basically identify high priority technology assessment needs and drive ideation for new emerging technology projects. It is a living document, so it is continually updated. So we update it based on responses to emerging and changes in the emerging technologies of interest, but also changing regulatory landscapes. So the different codes and standards that are implemented or will be implemented, those are definitely taken into account when selecting these different technologies and how it shapes this technology priority map in itself. So we try to update at least annually, but again, it is a living document. So this update is specifically towards the CFS. Now to kind of the structure of the TPM. For the top-down structure, at the top in the gray, you see TPM category, which really is kind of like a broad grouping of the technologies based on their primary function and purpose. It kind of is an overarching area or field in which each technology operates. And then below that, we have technology families. So it's kind of a collection of related technologies that kind of share common features, standards, or kind of built on the same design principles. So these technologies are within the family, these technologies are often variants or versions of each other, as you can see from the examples shown. And then within each technology family, we have subgroups, which are more specialized subfamilies, so to speak, based on things such as advanced controls, condensing versus non-condensing, storage water heaters, such as that. And then at the bottom of the hierarchy, we have the actual technology name for each of the technology that we're assessing and trying to identify as the potential for impacting savings on the market overall and increasing adoption of energy efficient measures. So generalized update overall, what would happen this roundabout was that as the commercial food service was of interest, so major updates were done specifically to commercial food service categories, including adding new technologies, moving some measures to other categories to better align with the TPM categories based on new information and new trends of how these technologies are being used. But also a focus was and an effort was done to adding measure package numbers to existing and new technologies so that they have one for reference, so that they can be used for possibly updating or assessing the potential for a new measure package potentially. But also we were focused on updating technology readiness levels and priority. We titled technology priority levels for each technology based on what we think would have the largest impact on the market itself. New technologies that were added included things that were not already on the list. So we have high efficiency cheese melters, high efficiency deck type upright broilers, which we'll go into a little bit more detail if you're not already familiar with these. But also added information was done on existing items to the list itself, high efficiency infrared salamander broilers, automatic conveyor broilers, combination ovens, the latter two of which were already studied in a previous project and published studies from this program. So if you have not already attended the previous presentation or have gotten to take a look at these reports, they include more detailed information on conveyor broilers and combination ovens. I'd recommend that you go check those out. So here, minor updates were done relative to non-commercial food service. But in this presentation, we're going to go over the new technologies specifically to the CFS category because it did amount to a significant increase of information added to the actual TPM itself, comparably to what was already on the list. So a good amount of information has been added, and we won't go over really the minor and minute changes, which include the measure package numbers, TRLs, priorities, and technology naming and such. But if you want to get that information, I would refer you just to if you don't already have the updated published version of the TPM, I would refer you to the Get Program website to be able to download that, which is publicly available. So on to the CFS updates themselves. So the one of two of the new technologies that was added to the actual TPM is a high efficiency cheese melter. And this was after talking with a few experts in the field, kind of what the trends were on what's been increasing uptake. So in the past decade or so. So the high efficiency cheese melter was seen as something that had rapid growth in recent years. If you don't know what high efficiency cheese melter is, it's basically what it says. It does melt cheese, but typically it's used to maintain or finish products, melts and browns cheeses, or anything that could be used at a lower temperature of about 300 degrees or less. But as you can see, the figure to the left, these have open cavities. Typically, they don't have doors that cover these for reasons of having fast accessibility, but also they operate pretty much constantly throughout operating hours. So there's a lot of waste heat into the environment and just generally a lot of wasted heat with the typical models that are used in the market these days. So for this technology, we did categorize it as only a medium priority. It is an established technology with no measure package, but again, this is it's not used in all situations, but it is a widely used piece of equipment. And then we're seeing that the rapid growth in recent years and anticipated growth up until 2032, it's expected to expand. So there's a huge opportunity for increasing uptake and the more high efficient cheese melters that are on the market now. In terms of the barriers, we did find, as with other equipment that are on the TPM, is that these high efficiency models have higher upfront costs, but also there is a perception of low ROI from the customers. So it seems there is opportunity for us to demonstrate a clear ROI for the energy efficient models that can help overcome those higher upfront costs. So definitely an opportunity to do lab testing and demonstration of the units to be able to develop a well-established measure package with savings. And on the second item that was added, which wasn't already on the TPM, are a very specialized kind of broiler. They're high efficiency deck type upright broilers, and they basically consist of multiple cooking surfaces or decks stacked upon each other that have adjustable heating elements and cooking grates or cooking racks. So they're very versatile and they can cook multiple foods at once with different temperatures, and they're very controlled with closable compartments, sealable compartments to be able to provide the consistency in the product. So these are definitely something that are only found right now in very niche markets. For instance, these are more found in high-end steak restaurants, sit-down restaurants, to be able to cook, I guess, steaks at a very high temperature and control the output and the different I would say finishes of the steak itself, medium rare to mid well. So, but there's definitely a huge opportunity to be able to use these and adapt them to different types of cooking processes. But again, with like other technologies, as mentioned before, the key barrier would be that these do have high upfront capital costs compared to standard broilers. Standard broilers, as in typical range stove under fire broiler type equipment that is typically used for, say, steaks or anything else that's being used on that or being finished by that product. But These also have a lot of complex installations that may require professional assistance, but also since it's very niche, there's very limited supplier and manufacturer availability. So that might be an issue. At the time of this study, we found that a lot of the distributors do not stock these in bulk since they are not typically um, of their bulk sales. So they are typically used only for high volume applications, again, most often in steakhouses. And additionally, staff needs to be trained to use this type of broiler to be able to optimize the performance and not just waste more energy than it would be using, say, the conventional underfire. But among those barriers, we found several opportunities um, with these. So definitely the multiple broiler compartments allows for an increased cooking capacity in, say, a very compact, space-limited environment and application. You can have very even and consistent cooking since these are a lot more controlled as being they're not open flamed, so to speak. They also some models also provide internal blowers that break up smoke and vapors with filtered air to maintain high efficiency. So among ergonomic and also um, environmental things, it's also could be very highly efficient at the same time. So they also come these high-end models that or high efficiency models that we looked into also come with insulative lining and burning box traps that trap the heat from preventing it from radiating out into the kitchen, which is adjustable and provides increased ergonomics for the operators, which is also a big interest for restaurant operators or restaurant owners. It has the compact design. It compared to larger broilers, and it also has optional casters, which allows for movability. So these are pretty versatile equipment if used correctly. Lastly, it has grates that help create char marks on the surface, so you're not going to be sufficing the enhanced fluid or enhanced flavor or appearance that you would get, say, from a well-seasoned under-fire grill with cast iron. So these have been shown to be able to provide the same quality of product while still providing for an ideal for high volume cooking environments such as restaurants, catering, and also institutional kitchens. So um, most of these designs do have removable grates and dip trays to provide for easy cleaning compared to, say, maintaining a conventional upright broiler. If you ever worked with them, they're very messy to be able to clean and break apart the burners themselves. So there's new models in for these upright boilers that provide a lot easier self-cleaning designs and mechanisms in there just to make it not to be operationally more difficult. So added information to those that were already on the TPM, we found there was still high interest and even more interest in the high efficiency infrared salamander broilers. These are basically the cheese melters, but they operate basically at an operating temperature of about 550 and above. They basically are suspended or wall mounted above under fire broilers or ranges stoves of that sort. So these are typically integrated within the system itself underneath a ventilated hooded system. Um, they're typically used kind of the same way as a cheese melter, browning, broiling, but even cooking products at a really higher temperature. So basically anything you would need to be able to caramelize at a very, very high temperature, about 600-700 degrees. These also operate pretty much continuously throughout serving hours with an open design. And with them being so at such high heat output, there is considerable amount of heat that's being wasted into the ventilation systems. But so it doesn't have an established measure package. It is an established technology. But again, since it's not used in all applications, we didn't categorize it as only a medium technology priority. The TRL for it, again, for similar to the cheese melter and the upright boiler is 9, meaning that it is already commercially mature and ready for commercialization further. The barriers for these type of high efficiency infrared salamander broilers that we found is that there's an additional cost for the ceramic infrared boilers in which these use. So the more high-end models, newer models use these ceramic infrared boilers. Um, they there is also an expected retrofit labor cost that's associated with these wall-mounted units, which are typically integrated within, say, like a cooking system or a cooking wall where there's a lot of other equipment around it. So it's going to require a significant retrofit labor cost to be able to swap these in and out. Um, there are many opportunities for these salamander broilers. There are newer models that have claimed efficiencies up to 99%, ideal for broiling flat foods such as steaks and pork chops. So actually cooking the product itself. Um, there's also tabletop units that can avoid these retrofit costs and provide like a plug and play type application, which can save space, but still would require some type of kitchen hood ventilation system to maintain safety and comfort, of course, and to meet local standards and codes. Electric salamanders are best for low to moderate use and in places without gas lines, while the gas salamanders are better for the high volume output restaurants. And that's basically at any time, any situation, a restaurant's going to need high temperature, high volume, they're going to be using gas um, for the most part. Infrared salamanders produce a pretty concentrated heat, and it's pretty fast heating and fast cooking, making them a really good choice for busy kitchens. So they're even faster cooking than, say, the standard baseline salamander gas broilers that are being used. Um, and there's also an opportunity for dual fuel. There's also gas plus electric salamander broilers, dual fuel salamanders, that can use electricity basically for low temperatures during low demand and gas for higher temperatures at peak demand. So um, that is an opportunity as well to explore. Um, Upon that, there's also packages where under fire broilers and salamander broilers are kind of in an all-in-one unit, since they're typically you use them together when you're cooking products, depending on what you're cooking. So they're typically placed right next to each other. So an all-in-one unit would basically rid the amount of wall mounting and hood space and all that stuff. So that would be a great thing to look into. But also these infrared allows for more cooking, a precise cooking temperature to allow specific temps to be reached without overcooking things. So definitely maintaining food quality over anything else. Um, the high efficiencies still do have an open design to allow for loading of quick dishes. So, but they do have the loading deck which can go up and down. So a lot of there's different designs in here which try to minimize the wasted heat, but still, it seems like the way that they are being used in um, the more typical in industry is that they want to be easily accessible, fast access, and basically flexible with a wide range of cooking temperatures at a quick pace. So another technology that was we had added more information to, which was covered in depth in a previous study, but still holds a pretty good potential, is an automatic conveyor broilers. Basically, these are they're the same. They do the same thing as broiling as any other broiler, but they are, as the name suggests, they are automated in the sense that they have conveyor belts that can be automated at a speed, and the temperatures can be set at which you can vary the different types of things you cook in here. So you can be very consistent with it as well. The newer models also come with infrared, radiant kind of heating panels for consistent uh, heat transfer and minimize waste heat. Um, so these equipments are really good for high volume cooking, consistency, adjustable finish, typically used for burgers, chickens, pizzas, etc. Anything that could really be. These are very adaptable and can be used for almost a wide, an unlimited range of things. There's newer models that are being designed specifically for these specialty items, like poultries or something that's very specific. This technology has an existing measure package with an opportunity to be updated with these higher efficiency tiers. Um, so the barriers, as with other technologies, are the high capital costs, which is to be expected, but the training also associated with this. As you can see in the picture to the left, these can be pretty complex pieces of equipment. You can see over there they've got PLC controllers controlling temperature, and then probably another one controlling speed and everything. So I mean, it would require a level of skill to be able to operate these compared to, say, just using a broiler that's just operated continuously, where it's just basic knobs. So there is a level of training that does go into this to be able to operate these efficiently. Because you can imagine it could be pretty easy for somebody to not be fully trained and that they are using it, they're not optimally using it, and they're actually wasting more heat than they should be. So I think we assess proper training as being very critical to be able to use these, and why that's a barrier to people not using them. There's also, as mentioned in a previous study, that during the time that there was a long lead time for the specialized parts that go along with fixing these. So um, this could lead to another opportunity that you could suggest a specific spare parts inventory be maintained with, very high wear and tear parts in here, anything that basically is moving. So they would have to keep things on hand to be able to reduce that downtime from these long lead times that we have been told about these specialized parts for these equipment. So also with that, you need specialized labor to be able to maintain the equipment. So um, since these are mechanical, they're also electrical, plumbing, everything else. You basically have to have a handy or a contractor that can do all in one to be able to work on these. Somebody that's uh, specialized and qualified to be able to do it. But there's also opportunities again, and we added more information to the map, including the opportunities for this technology, uh, including its ability to replace conventional broilers. There's a growing trend for more compact um, restaurants, grab and go type restaurants that are using these, and they're very limited space capacity. So they're trying to be able to optimize volume output, but still maintain quality of food. So, and there's actually a growing trend in which we found that newer models can cook even more special food items. So it seems like the market is trending towards these being more specialized towards the needs of the customer. Um, but most importantly, we found that there are a lot of the new models compared with these what are called removable catalytic converters. Basically, the same thing it does for a car. It removes the need for a kitchen ventilation system, which is huge. If you don't already have one, you can imagine it's going to be very expensive to retrofit something in there just to have this. So if you were able to just get away with cooking with this and you had a removable catalytic converter, it would remove the need entirely for kitchen ventilation systems, which are required by code, but the catalytic converter rids that. So also, these do have improved ergonomics aside from everything else via the reduced waste heat that these are able to maintain, and the automated processes that reduce the operator, the need for the operator to be more vigilant, I guess. So everything's automated. Lastly, the last added technology that we added more information for, which still holds to be very promising, are the combination ovens. So if you're not already familiar, these are basically steamers and convection ovens, sorry, that are combined into one unit. So basically, you can do the best of both worlds, and you're able to really increase your ability to produce a wide a range of products, and maintain really high quality, as these are pretty advanced and automated. As you see over to the left-hand side, I included one that has a digital interface on the left-hand side, which you can see has icons for the different foods that you can cook. So it seems like there is already a bunch of engineering that goes into the programming of these to be able to make it easier for the operators. But still, we do find that there is a need for um, training to be able to use these optimally. So they are specifically engineered to handle high volume cooking demands while maintaining, consistent results. They are pretty well implemented in the European market, and they're gaining size now in the US. So we're seeing a big trend of adoption here. So for this reason, they are still growing. It's only classified as a medium priority. Again, TRL number 9. It's already a well-known technology in Europe and other markets, but it's only just gaining traction here in the US. So um, as with others, high upfront cost, but then also there's additional cost of water, plumbing, and electricity. So if you're just coming from using, say, a convection oven, then you want to add the steaming effect, then you're going to have plumbing that's associated with that, and the added cost for that, and the added labor. And there's also a big perception of how difficult these things could be operated. But again, as indicated by the figure over to the left, there's significant engineering that goes into making these operate as easily as possible, but still um, there is a perception that they are too difficult to operate and that they would hinder production. There is definitely a lack of awareness of the benefits. So these are definitely not well known for how they could be optimally used to increase your output um, while maintaining high quality product. Um, so definitely a lot of opportunities with this as well. So advanced control systems, for one, that would allow you to have precise regulation in cooking temps. You can usually combine multiple cooking methods in one, such as convection, steam, and sometimes even microwave and infrared cooking. So upon that, you can have a, a wide array of way of cooking, and that could just add to your possibilities of what you can put on the menu, basically. Um, some models provide rapid preheating. Some models are equipped with energy recovery systems that capture and reuse heat generated during the cooking process. Advanced insulation materials can be added to existing or new ovens to save energies. So that's also another area of opportunity that we can look at to be able to, as an add-on measure, so to speak. So there are water savings for these combination ovens compared to using steam ovens. So they're very efficient when using the water, um, if that becomes a concern for the operator. These units have very fast cooking times. They provide labor savings because a lot of times they have self-cleaning mechanisms. So compared to conventional ovens, which do not have those, in which you have to physically manually clean. And it also reduces monitoring of the cooking process, so freeing the operators up to do other things, to increase output in other areas. So these ovens do provide increased food safety and hygiene due to precise temperature control and self-cleaning features. So that's also very ergonomic and good for the operator. They provide for a better kitchen environment because they can be operated more quietly compared to conventional ovens. So they're definitely more quiet. They're with a lot less wasted heat. So there's a lot of benefits to these that are not well known. And a few technologies in which were recategorized and moved from other technology TPM categories were these three. Um, would be number one, under counter dishwasher. So basically, now the dishwashers that we're seeing in, say, bar type environments or any type of environment where they need quick washing, but also the large door type dishwashers, which are found typically in the back kitchen for the large capacity washing. And then lastly, we redefine something from another category, low flow pre-rinse spray valve. So as you can see over the left, that would be the one that the valve or the kitchen, I guess, aerator that's used for cleaning dishes, but at a high temperature, and it's saving water, which is saving on the gas energy used for water heating. So just to bring to the attention of Cal Next, uh, that they are focusing on the emerging electric technologies, as this program only focuses on the gas emerging technologies. So we wanted to bring to your attention, if you haven't already checked out CalNext's website, you can see more at the calnext.com. They have a wonderful website in which you can go through the different TPM categories you see here, the 6 different categories. So appliance plug loads, HVAC, lighting, process loads, water heating, and whole buildings. The same categories which are covered in the TPM for the Gas Emerging Technologies program. So we can open it up for any Q&A that anybody might have. Our next event we do want to bring to the attention will be on energy modeling and analysis of dual fuel heating systems in single family homes. That will be on October 22nd at the same time, 1 o'clock, and invitations will be sent out shortly. So if I would like to open it up to the floor, if anybody would like to put any questions, you can unmute yourself or put it in the chat, or if you want to follow up with the contact information on the next slide. Ava Donald, she's the program manager here for this GET program, and she would be happy to be able to send over and forward your information to us as a follow-up, and we can answer any questions. I do see we did have one question in the chat. So Paul Cook asked, what is the next step for these products? Are you developing measure packages for them? So we have identified those which we would like to develop measure packages for them. But at the moment, no, we are not at that stage. Potentially, this is mostly used just to identify which would be best to be able to develop a measure package and or update existing ones. So, but those would be, I guess, for a different project. And then also, Edward asked, oh, I'm curious what salamanders are claiming a 99% efficiency and where those numbers coming from. So yeah, those are definitely from the manufacturer specifically. So yeah, we definitely would like to do lab studies to be able to verify those numbers, but we can definitely, I can definitely follow up and look deeper into which models specifically we're claiming the 99 efficiency. I don't have that off the top of my head, but we can look into that and follow up with that information if you'd like.
Chris, are
Okay,
you?
so
Yeah, sorry. Never mind. I thought you.
okay, so yeah, so Paul asked, can you link the TPM document you noted? Kate, would you be able to provide that?
Yeah, I can grab it and
Thank you.
send it.
If there are no other questions, again, if you do want any follow-up information, you can reach out to Ava and she'll forward the information to us and we can get back to you as soon as possible.
All right. I think we're, thank you so much, Christopher. I think we'll wait one more minute to see if there's any other questions that come trickling in. But other than that, thank you for participating today, and we'll send over the webinar materials. Thank you.
Thank you, everybody.
Thanks, Chris. Thanks, Chris.
All right. Thank you, Chris, and I'll send over the documents.
You're welcome. Thank you, everybody.
Mhm.
Goodbye.